So the speed of a boat undergoing constant acceleration increases from 5 meters per second to 15 meters per second over a time period of 20 seconds. Alright, so let's go ahead. Here's the surface of the water. This is a horizontal problem now. So we have a boat, not the best looking boat in the world, but you get the idea. So V initial is 5 meters per second. And then 20 seconds later, the boat's down here somewhere. V final equals 15 meters per second. And the time between these 2 points, let's call this t equals 0, and this is equal to t equals 20 seconds. And we want to know how far the boat traveled during that time. Now there's a couple of approaches here. We could use the kinematic equations, but it's actually harder to do it that way. If you think back to some of the things you may have learned before you learned about the vertical motion and the acceleration of gravity and the kinematic equations, one thing that you learned is that for constant acceleration, the average velocity is equal to the initial velocity plus the final velocity over 2. And then of course you know the distance, delta x, is going to be equal to the average velocity times the time. And what this approach allows us to do is it allows us to solve the problem more directly without computing the acceleration as an intermediate step, although maybe I should demonstrate it that way also. So doing it this way, the average velocity would be 5 meters per second plus 15 meters per second over 2. That's 10 meters per second. Delta x equals 10 meters per second times the 20 seconds. So that's the 200 meters. Alright, now let's suppose that we weren't that clever and we wanted to think about the acceleration and solve the acceleration as an intermediate step. As you recall from the definition of acceleration, by the definition of acceleration, it's the change in velocity, and these deltas that I like to throw around all over the place always mean the change. So it's the change in velocity over the change in time. So it's V final minus V initial over the change in time. So 15 minus 5 is 10 meters per second over the 20 seconds. So 10 meters per second divided by 20 seconds is 0.5 meters per second squared. And now x final, let's go ahead and call this x equals 0, and this is our x initial equals 0. X final's down here by where the boat ends up. X final equals x initial plus v initial times the time plus 1/2 at squared. So this would be 0 plus 5 meters per second times the time, and the time is 20 seconds, plus 1/2. The 1/2 comes from there, and then the acceleration is 0.5 meters per second squared, and then the time is 20 squared. So 5 times 20, this term here gives us 100 meters, and then 20 squared is 400, and then 400 times 1/2 is 200, and then 200 times another 1/2 is another 100. So it was a little harder to work out that way, but we get the same answer. It was a pleasure working these physics problems for you today. Hoping you'll give me another chance real soon.